Welcome back, guys. Today we're going to have another look at equivalent fractions, and I wanted to start with something a little bit more complicated than what we had the other day, because the other day we learnt that, for example, if I had 1/4 like this, it would be the same as 2/8. So that's a very simple way of saying equivalent fractions. But where it gets more interesting, where there's more sort of juiciness, is when you get non-unit fractions like this. So you can see I've got 3/4 placed there. And I wanted to show you this one as well, which is very much a similar sort of thing. That is 6/8. Now they look a bit different. This one's been chopped up more times. This one has only been chopped up 4 times and there's one piece missing. But they cover the same area, and that's all equivalent fractions are. 2 fractions that cover the same area. Now, what I wanted to get to was the fact that we can make this less about guessing and more about mathematics. What I want you to notice here is that for every 1/4 there are 2/8. So the relationship between 4 and 8 is 2. You half 4 to get that many pieces. Well, in this case you actually double 4 to get 8, but what we're talking about is chopping it up more times, right? So that's all we're going to start with our equivalent fractions. It's just sort of saying, well, if I've got 3/4 of these, it's the same as having 6/8 of these, and there's a mathematical relationship between the two numbers. Now, not all numbers can match up, obviously. So if I had, for example, 2/3, you can see it's nowhere near the same. And even if I jammed another 8 in there, an eighth, sorry, it's not the same. It doesn't cover the same amount. So not all fractions will match up, and that's where the maths comes in, is seeing the relationships between the two sets of fractions. So if I had things cut into 1/6, for example, instead of 1/8, I could definitely make that, but it would be 4/6. If I chopped each of these in half like that, I would need 4/6 to cover the same area as 2/3. Now I don't have any 6th here, but you get the picture. So let's have a look at numbers instead and see if that can also make sense for you. Okay, let's have a look at this wee fraction here. It says 4/16. Whatever thing I have has been chopped up into 16 pieces, and we're talking about 4 of them. But if I wanted to find an equivalent fraction, I can think of numbers that I could divide both of these by. So if I wanted to do something really simple, I could actually divide them both by 2, couldn't I? So if I said 4 divided by 2 gives me 2. 16 divided by 2 gives me 8. So I could say 4/16 is the same as 2/8. Now other ones that are the same as well, other ways of chopping it up. Absolutely there is. What if I chopped it by 2 again? What if I divided it by 2, these 2/8? Can I get an even simpler fraction? Yes, we can. Well, 2 divided by 2 equals 1, and 8 divided by 2 gives me 4, and you'll see that that's a very familiar fraction indeed. So this 2/8 is an equivalent fraction, covers the same area. 2/8 covers the same as 4/16, and this is the simplest fraction, 1/4. All of those cover the same area, 1/4, which looks like this. So that's this one here. And then if I had, find my bit of paper, 2/8 would look like that. And 4/16 would be like these chopped in half again, which is possible to do, but we don't have that with us here right now. But you get the idea that 4/16 covers the same area as 2/8, which covers the same area as 1/4. Now, can we do it with other numbers? Absolutely we can. Okay, what if we had something like 3/9? We're thinking about a pie or something that's been chopped into 9 pieces, and we're talking about 3 of those pieces. Now, some numbers can only be chopped up or divided up into simple ways. So there's only a few ways I can divide these numbers up. I can't divide it by 2, but I can divide them both by 3, can't divide them by 4 and 5 and so on. So some of the numbers will just make sense on how you can chop them up. So the sensible thing here is to divide both of these numbers by 3. 3 divided by 3 gives me 1. 9 divided by 3 gives me 3. And you can see here that 3/9 is the same as 1/3. It would be as if I had 1/3, but 3/9 would be this chopped into 3 pieces, if you make sense, because I would need 9 pieces chopped up to make my full circle, but we're only talking about 3 of them. So 3/9 is the same as 1/3. Okay, let's try another one. In fact, what I'll do is I'll write one up and get you to have a go for yourself and see what you come up with. All right, have a go at this one. The object has been chopped into 12 pieces, but you're only talking about 4 of them. So what's an equivalent or simple fraction that I could use to describe the same area? Okay, if you're having a go for yourself, just pause there and then we'll come back to it straight away. Okay, so let's have a look at our 2 numbers. What can I divide them both by? Well, I could divide them both by 2. That would simplify things a little bit. I could go half of 4 equals 2. And I could say half of 12 equals 6. That's an equivalent fraction. It's true. This covers the same area of that. Could I simplify it even further? Well, yes I could, because both of these numbers also can be halved. I could go divided by 2, divided by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So 4/12 is the same as 1/3 again. This thing's been chopped up more times, but it covers the same area as 1/3. Oh, okay. That's a bit interesting. Now these end up being unit fractions, don't they? So I wonder if the same would work if the ending up fraction was a little bit more complicated than that. Let's have a look. Okay, now we're getting a bit serious. Our denominator, 20, means that our object has been chopped into 20 pieces, tiny slices. And we're talking about 12 of them. Now, straight away, you can tell that 12 is a little bit more than half, so I can't just say it's a half. It's not close enough. But how can we chop it up to make sure we get the right numbers? Could we do something like halve them both first? Yeah, okay, we could. So we could go divided by 2, divided by 2. 12 divided by 2 is 6. 20 divided by 2, of course, is 10. Got ahead of myself there. So 12/20ths is the same as 6/10ths. Could I simplify that again? And as we've seen before, sometimes the easiest way to get to your simplest fraction is using steps of equivalent fractions. So we can see, yes, we can divide these both by 2 again. So 6 divided by 2 is 3. 10 divided by 2 is 5. Now both of these are prime numbers, so we can't chop them up anymore. So 12/20ths is the same as 3/5. Now, is there a quicker way to do this? This seems like an awful lot of writing. Well, yes, we could. In our minds, we can take one of the steps out. We know that the answer is 3/5 with this one. Let's see if we get it just by doing it in a slightly faster fashion. So we started with 12/20. What's the biggest number I can divide both of these numbers up by? Well, I could go through one at a time. Yes, I can divide them by 1. Yes, I can divide them by 2. We've already tried that. I can't divide them both by 3. Can divide 12 by 3, but not 20. How about 4? Yeah, 4 looks promising. 12 divided by 4 or 20 divided by 4. 5, no, that's in the 5 times table, but that isn't. 6, no, 20 isn't in the 6 times table. 7, and now we're just getting ridiculous. So I think the sensible answer would be 4. Let's see what happens. So divide both of those numbers by 4. 12 divided by 4 is 3. You can see where this is going. Then 20 divided by 4 is 5. Oh, that's what we knew the answer was going to be 3/5. But this was a lot quicker than dividing by 2 and then dividing by 2 again. Now, if you've seen my other division videos, you'll know that divided by 4, you can divide twice to get what you want. But this is more efficient. It does require that you know your basic facts, though. Let's try. I'll give you one more to try, and then we'll close it up for today. Okay. This is going to end up with a non-unit fraction answer. It's going to be a number over another number that is not just 1. So how can we begin to chop this up? Well, again, I wouldn't worry about going through all of the numbers, writing them out, that is to say. What you can do is just use your imagination to figure out what numbers you can divide this by. So have a look first, pause it here if you need to, and see what number you can easily divide both of these numbers by. Your process might have been, well, I can easily divide them by 1, but there's no point. 2 doesn't work. 3, no, can't divide 10 by 3. You can divide 15. 4, no, neither of these numbers are in the 4 times table. 5. Oh, 5 is looking promising. What would happen if I divided 10 by 5? Yes, I can do that. 15 by 5. Let's try. So we go divided by 5, divided by 5. 10 divided by 5 equals 2. 15 divided by 5 is 3. So if you ended up with 2/3 for your answer, you're absolutely right. Now, it can be a bit confusing. You're saying 10 and 15. What? How did I end up with 2/3? But if you think about it, if I had a slice of pizza and I'd chopped it up into 15 pieces, I've kind of lost the bottom of it there, I'd need lots and lots and lots and lots of pieces. But if I had 10 of them, it would look like 2/3 of my pizza. That's more like that. So if I had 10 slices in there, really rough drawing, but it makes sense when you think about it. So 10/15 is the same as 2/3. So this is a very good way of finding equivalent fractions and simple fractions.